In Lesson 13.3, we're studying histograms. You'll learn how to interpret data displayed in histograms and display data in histograms. How are histograms used to display data? A frequency table shows the frequency of events. The frequency table below shows the number of states with the mean SAT verbal and mathematics scores in each interval. The data are from the 1999-2000 school year. And notice their intervals do not overlap. They went from 480 to 500, not included on this end, and then it's counting the 500 to 520. So because if you counted both ends or didn't count both ends, you wouldn't know what to do with the 500. The distribution of the mean scores on the SAT verbal exam is displayed in the histogram. So for the bar that went, so for this interval of 11, 11 obviously goes a little past 10. They only numbered by twos. So there's our frequency of 10, 6, 8, 10, and 5. They didn't put one for the 0 for some odd reason. The graph above is called a histogram. A histogram is a bar graph in which the data are organized into equal intervals. In the histogram above, the horizontal axis shows the range of the data values separated into measurement classes. And the vertical axis shows the number of values or the frequency in each class. Consider the histogram below. Again, the frequencies are the heights of the bars. And this is an important part. The width of each bar is the same. They're all 5 units. And there should be no overlapping. Rats. Because what would you do with that 25? That's kind of a bad histogram. There are 7 classes in the histogram. Note that although 45 through 50 has a frequency of 0, it is not a measurement class. Another difference between a histogram and any other kind of bar graph is there is no space between the bars. They are supposed to be right next to each other. In what measurement class does a median occur? Okay, remember median is the middle of our list. So we're going to have to figure out how many are in our list before we can find the middle of our list. Okay, so if we just add up our frequencies and they were nice to us and labeled them, we didn't even have to read them off of the bar graph. We get a sum of 24 numbers. So we're looking for half of 24, we're looking for number 12. So 2 plus 2 is 4, plus 7 is 11. So the number between 12 and 13, or 12, yeah, would be our median, would be in that next class. So the median falls in the 20 to 25 class. Describe the distribution of the data in histogram. Only 2 homeroom classes have fewer than 10 students. There's a gap in the 5 to 10 measurement class. Most of the homeroom classes have at least 15 students. Okay, and the most important one, the distribution is skewed to the left. Skewed to the left. Okay, I would want to call this skewed to the right as well, but this is called skewed to the left because the tail is to the left. So the skew direction is where your little part is, not the big part. Use the data in the histograms to determine which class has a greater median test score. Both sets of data have 24 items. So again, 24 divided by 2 is 12. So to find the median, it's going to be between number 12 and number 13, the 12th and the 13th items here. So I've got, just adding 2 plus 5, that's my 7th, plus 7 plus 9 is 16. Okay, so my median is going to be in the 80 to 90 there, and 2 plus 4 is 6, plus 8 is 14. Again, it's in the 80 to 90, so they should be about the same, even though we don't know exactly what they are. They're in the same measurement class. Create a histogram to represent the following scores of 25 winning college football teams during 1 week of the 2001 season. Okay, the smallest score was 21, and it looks like the highest is 52. So they set their intervals to go by fives, going from 20 to 55. And then we're making tally marks like you've done forever. So when you're making the tally marks, obviously you're just going to count 43. So it's in the 40 to 45 mark. Make a tally. 52. Make a tally. And then we're on 38. So find the section where 38 is going to go. Make a tally. 36. Make a tally. And when you get to 5, you cross over. The frequencies here are just counting up the tallies, which makes it nice. And then all I did was translate the frequencies into the height of their bars, and they're all nice and equal width. They broke their own rule, because here it says it's 20 to 25. The 25 is not included, so this should be a 24. The 30 was not included, so that's 29. Okay, so this is me being irritated with the book, but these things happen. Okay, so where they had the not equal to, it should not include that value. Hey, this is edited and copyrighted and published, so, we'll get over it. A histogram can illustrate the information in a frequency table. The distribution of the data can be determined from a histogram.